I'm going to work through problem 5 on page 149. This is the one where I think, at least my understanding, there's a mistake there. So I thought it'd be easiest to work it on here. I'm going to work it with a distance of 150. Okay, so what we know, it says that the object has an initial velocity of 75 feet per second, and that's my understanding. It's not up, it's not right, it's that's at the angle that's unknown. Has an initial position, not pi, but initial position of 5 feet. And the I'm going to make this delta x, I'm going to call it as 150 feet. Okay, so basically what's happening, you have an object being shot from about 5 feet off the ground, and it goes up, comes back down, and it's going to travel 150 feet. Excuse my handwriting. So this vector here, let's make it a different color. This initial vector is at 75 feet per second, and we can kind of break into its components, Vx and Vy. Now Vx in a problem like this is constant, so we don't have to worry about it changing, but Vy will be subject to gravity, so I'm going to call it Vyi. And those values, Vx is going to be 75, we'll make this theta, 75 cosine theta, and Vyi is 75 sine theta. So we have a number of unknowns here. We're trying to find out what is that launch angle theta. Okay, I'm going to go to new slide. So we, what I like to do in these kind of problems is have a kind of a vertical analysis and a horizontal analysis. Typically the vertical analysis is the more complicated one because you're dealing with gravity. Horizontal, you have a constant velocity. So in the vertical analysis, we know, because this problem's in feet and we can assume it's on Earth, we know that we have a constant acceleration of negative 32 feet per second squared. Velocity is the integral of acceleration, so it's negative 32 t plus the initial velocity, which is 75, and this, again, this is going to be the, wow, this is your Vyi. It's your initial velocity in the y direction. And I always encourage my students to write all three of these out before they even do any thinking. So we'll do that. So integral of negative 32t, and I'll stick a t on the end of this. And then this is plus initial position, which was told to be 5. So again, that was initial, I'm calling pi, initial position. So now it's time to think. We're trying to find out, well, we know it's going to hit the ground 150 feet, but we don't know how to find that angle, where we're going to get that from. So we need to come up with equations that include theta. So one idea is, well, if it's going to hit the ground 150 feet, I need to use that. So we know, I call this a hidden truth, we know that when you hit the ground, that means your position is 0, your vertical position is 0. So I can make this equal to 0. Put the t here so I don't lose it. Okay, hopefully you can read that. So let's see, just to make sure we can tell with my bad handwriting, that's a plus, that's a plus, that's a t. Okay, well, how do we solve this? We have two unknowns, a t and a theta, so we're stuck. So what else do we know? Well, horizontally we know that this thing is traveling Vx, and horizontally it's very simple, it's constant velocity, so velocity is displacement over time, horizontal displacement over time. We know a representation of horizontal velocity is, what was it, 75 cosine theta, and I made my delta t, that's delta, can't even tell what that is. I made my delta t 150. It's a pretty good choice, I must say. And we don't know what t is. So this isn't going to get us anywhere, it looks like, either, but let's just simplify a little bit. And we'll have it's 150 over 75 cosine theta, which becomes 2 secant theta. So that's pretty important. That's pretty important. But neither one can be solved, but we see we have two equations, two unknowns. That's a good place to be. Let's go to the next slide. Okay, so let's plug in that value of t, and that's going to give us something a bit long here. We'll have 0 equals negative 16 times 2 secant theta all squared plus 75 times 2 secant theta times sine theta plus 5. Okay, do a little simplifying. Negative 16 times 4 times secant squared theta plus, this becomes 150. Let's make this sine theta over cosine theta, because we know secant's 1 over cosine theta. That'll be a little friendlier to work with, and we can eventually change it to tangent. So this is going to be negative 64, negative 16 times 4, secant squared theta plus 150 tangent theta plus 5. Okay, well, we have an equation only theta's looking pretty good, but we have, in a trig equation, you prefer to have just one type of trig function. We have secants and tangents. I call these Pythagorean buddies because, well, they have a Pythagorean identity. Their derivatives are nicely go together, but the key for us is the Pythagorean relationship. So we can go all in with tangents here by changing this to 1 plus tangent squared theta. Okay, there we go. And then we can distribute. I'm sure you could do the rest of this probably. And I'm going to do a little cleanup here and move everything to the right side to get positive leading coefficient. I just like that kind of thing. Minus 150 tangent theta, and it's going to be what, plus 59. Okay, so what I did next, and again, you probably can you can stop this if you want. I don't have any other amazing things to show you, but we can let u equal this, and therefore we have something a little more familiar to us. There we go. Let's go to the next slide. So that quadratic, I just actually works out pretty nice. U is 0.5 or a half, and 1.84375. So which is like 59 over 32, I think. So we'll go back and say, well, we didn't really want u, did we? We wanted t, or we wanted theta. So we'll say, okay, u equals, we'll say that u equals tangent theta. We learned, right? So we can say 0.5 equals tangent theta, or 1.84375 equals tangent theta. Solve each of those, and they come out to be about 26.565 degrees and 61.526 degrees. So two answers. Yeah, there's two answers because when you fire a trajectory, there's an optimal angle. If you go just above it or just below it, you're going to go the same place. So it's not too shocking to see that there's going to be two solutions if I'm doing this right. But I did plug those in and tested them, and they worked. So hopefully that helps. See you later.